Hello and welcome to this Dr. Frost Maths video on Key Stage 5, adding and subtracting algebraic fractions. This is largely a recap of what you did when you were younger, but some of these harder questions you may not be familiar with this type unless you've done some kind of further maths GCSE qualification, for example. Now let's just recap how we actually add fractions together, and that will give us the underlying principle behind this. If I had, say, 2/3 plus 4/5, then one way you can do that is to multiply the denominators. So we do 3 times 5 is 15. And then you cross multiply the numerators. So the 2 gets multiplied by the 5 to give 10. And then you add the 4 gets multiplied by the 3 to 12. And then we know that is just 22 over 15. And then we could simplify that fraction further. So let's use that principle here. We want to multiply the denominators and cross multiply the numerators to add or subtract these. So we've got 1 over x plus 2 minus 2 over x minus 3. So as I said, we multiply the denominators to give x plus 2, x minus 3. There's no need to expand that, we can just leave that factorised, and then we cross multiply the numerators. So we get 1 times x minus 3, and then we're minusing 2 times x plus 2. I'm not going to try and do too many steps at once, because a common error that students make is they just write minus 2x plus 4 here, without realising that that 2, when you multiply it by minus 2, is going to become negative. So when we do that, we get, well, x minus 3, when we expand this all out, minus 2x, and it's going to be minus 4. And we can leave, again, this denominator unexpanded. The reason we have to expand this but not this is because this is not a product. This is overall a subtraction of two things, whereas this is a product, which means it's factorised, and we're allowed to leave things factorised. And then this just simplifies to, well, x minus 2x is minus x, and minus 3 minus 4 is minus 7 over x plus 2, x minus 3. What about the second one? So we've got x over x plus 3 plus 3 brackets 2x plus 1 over x squared plus x minus 6. Now, the way we do this is try and factorise everything we can first, because we might identify there's actually a common factor here. Now, x squared plus x minus 6 factorises to x plus 3, x minus 2. Now we could just multiply these two together and do it in the same way, but the thing is these have a common factor. Like if we had, say, for example, half plus a quarter, there's no need to multiply these two together to get 8s. We could just multiply top and bottom of this by 2, and then these are common denominators, so it would just be 3 over 4. And we're going to do the same kind of thing here. So can you see that if we just multiply top and bottom of this by x minus 2, then that would be x plus 3, x minus 2, which would match this. So let's do that. X brackets x minus 2 over x plus 3, x minus 2. So that's just the first fraction. We've multiplied top and bottom by x minus 2. Sorry about that. And then we've still got that second thing here. So we've got 3 brackets 2x plus 1 over x plus 3 times x minus 2. And now, because it's a common denominator, we can just add these top things together. And I'm going to expand out at the same time. So we've got x squared minus 2x plus 6x plus 3 all over x plus 3, x minus 2. And then that just simplifies to x squared minus 2x plus 6x is plus 4x plus 3. Then we've got over x plus 3, x minus 2. Now you might find at this stage that once you've combined them into a single fraction, you can actually simplify this fraction. And we're going to have to do that by factorising. So this numerator here factorises to x plus 3, x plus 1. And that looks promising because we can see there's a common factor, top and bottom, of x plus 3. So now we can just divide top and bottom by x plus 3, and that gives you a final answer of x plus 1 over x minus 2. And then this final question here, we've got 3 fractions now being added or subtracted. So I'm going to use the same strategy of just making sure everything is factorised first in the numerators and denominators. There's nothing to factorise so far, but this third fraction here, we can see that the denominator is the difference of two squares. 4x squared minus 9, that could be written as 2x plus 3 and 2x minus 3. So at this point we use the same strategy. We consider what would be a common denominator. Well, they all have 2x plus 3 and 2x minus 3 somewhere, so we could therefore use 2x plus 3, 2x minus 3 as the common denominator. So let's do all in one go. What do we need to multiply top and bottom here by to get that at the bottom? Well, the 2x plus 3 is being multiplied by 2x minus 3, so we simply have to times that 3 by 2x minus 3. Now I could do these as separate fractions, but I'm just going to combine them in one. Minus, now that has been multiplied by 2x plus 3, so I have to times this by 2x plus 3 as well. So it's just minus brackets 2x plus 3. I'll put the 1 on the front. And then finally, this 6 doesn't need to be multiplied by anything because we've already got that same denominator. So that's just plus 6. So I'm now going to expand and simplify the numerator. So that's 6x minus 9 minus 2x minus 3. Be careful of the signs. Plus 6. And remember, we can just leave the denominator as it is because it's factorised already. And then that numerator simplifies to 4x minus 6. And as we would usually do once we combine it into a single fraction, we see if we can factorise it further. Now the 4x minus 6 has got a common factor of 2, so it's 2 brackets 2x minus 3. Oh, that's handy. So we can see there's now a common factor of 2x minus 3. So we can cross those out by dividing by them, and that just leaves us a nice simplified answer of 2 over 2x plus 3. And to be honest, if your fraction really nicely simplifies down like that, then you've probably got it right.